Hi everyone, welcome to Unit 1.6. Today we're talking about boundedness and symmetry. Okay, so there are two different parts to our lesson today. The first thing that we're going to talk about is boundedness. So this is something that we look at graphically. Okay, and we want to see the limitations on the graph. So does the graph fail to point all the way up, meaning can it not extend upwards? Well, then that means that it's bounded above. Okay, is the graph stopped from extending all the way down? That would mean it's bounded below. Okay, if we have a function that stops from going up or down, okay, in both directions, that's called bounded, or you could also say bounded above and below. Okay, you could specify. And then, does the graph point in both directions? Is it fine to extend everywhere? Then that means it is not bounded or not bounded above or below. Okay. All right, so we're going to take a look at some graphs. You're going to need your grapher for this. Okay, you're going to plug in, or if you know just by looking at this that is a quadratic function, that is very helpful as well. Okay, but if you plug in your function, okay, and you look, this is a negative parabola. Okay, so that is what your graph would look like. It's pointing downward. So is this graph being bounded anywhere? Is it being stopped? Okay, so you could also think, does it have a floor or a ceiling to the graph? And that'll help you determine boundedness as well. Okay, so this graph happens to be bounded above. Okay, so we see that the function cannot go any higher. Okay, it appears to have a ceiling. Okay, number 2, that's a cubic function. So if you plug that into your grapher, okay, you're going to get something that looks like this. Okay, so what would we say is our boundedness here? Okay, is the graph able to point upwards? Is the graph able to point downwards? So in this case, we can go both directions, which means that this is not bounded. Okay, so boundedness is a very, very simple concept. Okay, you're just asking yourself, can the graph go up? Can the graph go down? All right, we'll look at 2 more examples. So these can be plugged into your grapher. Okay, so sine of x, you may not have ever seen this graph before. It's okay, you're not being asked to graph this by hand. All right, you want to generate this. And what can you see about this function is that it seems to oscillate and it just keeps going. Okay, but does it extend all the way up on the graph? Or is it stopped? Does it have a ceiling? And can it extend all the way down? The answer is no, it can't. Okay, so this function is bounded, okay, which is bounded above and below. Okay, our last function here, number 4, this is an absolute value. All right, you know that graph is the shape of a V, so you may not have even needed the graph here to determine. Okay, but we see that this graph has the ability to point all the way upwards, to extend, okay, but it cannot extend down, which means that this is bounded below. Okay, so boundedness, you will always be asked to do this visually from a graph. So if just the function is provided, you are typing this into your grapher and producing, okay, that visual in order to determine your boundedness. All right, up next we are looking at symmetry. So symmetry and boundedness have nothing to do with each other. Okay, they are just two characteristics, two aspects of graphs that we can analyze. All right, so there are three types of symmetry that we're going to look for. Okay, even functions are symmetrical with the y-axis. So that means if you were looking at the graph of an even function, you would be able to fold your paper and make a crease down the y-axis, and the graph would fall on top of itself on each half. Okay, odd functions, similar, okay, but this is symmetrical with the origin. So in order to get your, like if you had a paper graph, in order to get this to fall on top of itself, you would have to fold it along both axes. Okay, so you would first fold it along the x, and then you would fold it along the y, so you would end up with one little square of a piece of paper rather than four whole quadrants, but the graph would then fall on top of itself. All right, and lastly, we could have x-axis symmetry. Okay, so that means if you folded your paper and creased on only the x-axis, you would have two symmetrical halves lying on top of each other. Okay, now symmetry we are not going to do graphically. Symmetry is going to be done algebraically. Okay, so we must show our work to prove symmetry. Okay, we cannot just simply state, oh, it's even, it's odd, I can tell from the equation, I'm looking at the graph. We are proving it algebraically. This is very important. Okay, so what does it actually look like when I have an even function, and what does it mean? So for even functions, I can take a positive and a negative x value of the same number, and it produces the same y value. So positive 3 and negative 3 are producing the same y value. So if I very quickly plot these points, maybe not so quickly. Okay, we see that if we folded our graph here and creased it on the y-axis, that I would get two symmetrical pieces that would fall on top of each other. Okay, so this is an even function. Okay, so same idea here. For odd, okay, when a positive and negative x value are plugged in, okay, they're resulting in the same y value with opposite signs. So negative 3 produces a negative 27, and positive 3 produces a positive 27. Okay, now I'm obviously not going to get 27s on my graph. Okay, so we can just estimate where that would go, kind of hanging off the graph there. Okay, but this is a cubic function. Looks something like that, okay? But if we folded this, first folded it down along the x, and then half that paper we folded here along the y, okay? Those two pieces of graph would fall on top of each other, and that would make this an odd. So they would have symmetry over the origin. All right, and our third one here, okay, x-axis. These are not actually functions, okay, because the same x value is producing two different y's. So you can see here, 9 and negative 3. Whoops. Does not like me today. All right, so, 9 maps to -3, and 9 also maps to +3. So not functions. Oops, that's the wrong one. Okay, but folding this along our x-axis here, you can see that those pieces would fall on top of each other. All right, so we're going to use these characteristics of the graph to prove this algebraically. Okay, so these are our 3 rules and how we're going to show this. So our test for symmetry, for even, okay, in our function, we're going to replace all of the x values with negative x. And I'm going to show you all of this in just a minute. Okay, but that's your rule. So for even, you're swapping out for negative x. Okay, for odd, we're going to replace both the x's and the y's in our function for negative x and negative y. And to prove x-axis, okay, we're going to replace all of the y's with negative y. Okay, so just be careful because this is on the other line. It's negative y that we're replacing. Okay, so those are your 3 rules. I'm going to show you how to prove each one. All right, so we're going to start off with proving that this function is even. Now, this is not always the wording and the directions that are going to be used in the problem. So a lot of the time it's going to say, determine the symmetry for this function. And you will then have to cycle through, try and prove that it's even, try and prove that it's odd, try and prove that it's x-axis. So you may have to do all 3 before you come up with an answer. Okay, because maybe it's the 3rd option that you try and you wouldn't know that just by testing even and odd. Okay, but just so that we can get the process under our belt here, okay, we're going to say prove that this function is even. So even means we switch everything, all the x values, for a negative x. Okay, so all of my x values, I'm going to evaluate this function with a negative x. So what happens when I do negative x squared? I actually get back to an x squared, and -5 hasn't changed because that wasn't a variable. So I can prove that this is now even because after plugging in for a negative x value, I got back to my original function. That's always the goal. Okay, so your goal is to show it matches the original function okay, when you use one of your tests. So I'm using the test for even right now. Okay, even is replace with negative x. So I plugged in for negative x and I matched it to my original function, all of the signs and everything. So this function I have just proved is even. Okay, let's try another one. So now I want to prove that this function is odd. So my rule for odd was replace both the x's and the y's with negatives. So that means negative y, so instead of f of x, negative x cubed and negative x squared. So I'm going to leave that negative y for a second and I'm going to work on the right side. So what happens when I cube negative x. So when I cube negative x, it actually stays negative x cubed. And if you're having trouble determining, what is negative x cubed, I don't know where everything just went, sorry. Okay, so like I was saying, so plug negative 1 cubed into your calculator. Plug negative 1 squared and make sure that you use parentheses, and that'll tell you what outcome you're supposed to have. Okay, so this would be a negative cubed. Okay, so this portion here is going to be an x squared, but since it's 4 minus, it's still appearing as 4 minus x squared. Okay, and now these negatives you can actually multiply or divide out over here to get rid of this negative 1. Okay, so those would cancel, and on the right side I would just put it over 1 since I have a fraction, and across the top and across the bottom those negatives cancel. Okay, so I get back to x cubed 4 minus x squared. So I'm fully simplified now, and I want to ask myself, does this match the original? Okay, as long as it matches, you have proved whatever rule you just plugged in for. So I plugged in for odd because I switched the x and the y. And since I can simplify and get back to the original function, that means that this is odd. Okay, so now I want to prove that this is not even, not odd, and not x-axis, which means I have to go through all 3 rules here. Okay, so for even, we just changed the x. Okay, so negative x squared minus. Okay, so remember, if you're having trouble with those exponents, just plug it into your calculator. Negative 1 squared, use parentheses. Okay, so this is my simplified. This does not match the original function, no. So that means that this is not even. Okay, moving on. Now I want to check odd. So for odd, I switch both the x and the y's. Okay, I could divide both sides by that negative 1. Okay, well that flips my negative x squared, gives me a negative 2x, and gives me a plus 2, so this does not match either. So this is not odd. Okay, remember, in order to prove, you have to show that it matches after you plug in the rule. All right, the last is x-axis. Okay, for x-axis, we switch to a negative y, but everything else stays the same. Okay, so that means all I would have to do is divide by negative 1 in order to try and simplify. Okay, but the signs here do not match. So this is not x-axis. So what does that mean for this function? All it means is it does not have symmetry. Okay, so you could have none, no symmetry. You could have just one, say it's just odd. You could also have 2 or 3, okay? It could be even as well as x-axis. It could also be all 3, okay? So there are expressions, they may not be functions, okay? Because remember, x-axis, okay, is not a function. So they may not be functions, but we could have expressions that are all 3. They could be even, odd, as well as x-axis. So sometimes you may have to test all 3, like I've just done here. Sometimes you may only have to test 1 or 2 before you arrive at your symmetry. Okay, you can use your grapher to, give you a starting place. So if you look at the graph and you say, okay, well, this looks like I could fold this across the y-axis, so I'm going to start with even, okay? And then you show algebraically that you're testing even symmetry, okay? But you do have to show the work. We cannot just use the graph, all right? So make sure that's everything for boundedness and symmetry. Make sure that your notes are complete. You write down any questions that you have.